Yeah, I'm Ajay from IBM. I work in the Netezza database. I have many years of database development experience. I'll be covering the Presto and Iceberg use cases, scenarios, overview, and then we have a next part which Beinan is going to cover on the Alluxio part of that. So yeah, next slide. So the agenda is watsonx.data architectures that we've seen today in the keynote, why Apache Iceberg, multi-engine support, open source Java, toolkit Iceberg, and just the adaptation trends and what we have done in the Iceberg and Presto area, the work. And then we'll have the last, the Presto Iceberg ML pipeline description in that. So yeah, just to give an idea of the overview from today's things, watsonx.data, it's an open, flexible, cost-effective model, what you have seen in most of the cases here, presentation. So it's an open, flexible model, and it's basically for the data management and for the hybrid cloud environment. So that's the main theme for that. So the next is how we have basically IBM has adopted the open source technology based on a different format. So just to give an overview that I'll be just talking about the Iceberg thing, Presto and Iceberg in this, but this is just a generic overview of what are the open source technologies that the IBM is using along with its own technology for the combination of the both technologies in that. So yeah, as you see, now we are using the query and for the query engine, the Presto and Spark both combined based on the different data formats. You can see underneath the governance security model, metadata layer is there, and then storage and infrastructure. So that's key components with the basic idea is the multi-query engine and using open table formats in the watsonx environment. So yeah, so this is what we have seen today, the architectural overview of the watsonx.data. What you can see, the Presto environment in the multiple workers and coordinators. So that has been used in this architectural diagram. So this is to give the idea that yeah, it's using the Presto underneath. So that's so then it's basically I'm just going to talk about the Iceberg thing, the why it has been basically used. It's the default choice. You can see just the performance, bringing simplicity to the big data and data lakes here. Fully open source, accessible, this thing. So that's a default choice that you can see. So it has on the right hand side, if you see full schema evolution, native encryption, hidden partitioning. There are many features or the components of that which has been used widely, adopted this thing in the Iceberg community or the spec. And that has been improving with the latest Iceberg versions, and different features have been added or it's going on. So that's the main focus, or that's adaptation, and that's why it's a kind of a default choice that we have been using or focusing in that Iceberg open format. So yeah, then yeah, so again back to the multi-query engine support. What you have seen today is, sorry, I'll go back. Yeah. the Presto Spark for the IBM Lakehouse. And what you have not seen is the multi Netezza and IBM DB2 warehouse, how they are going to, they can access the data from the Presto side, and they can again do a write and use underneath objects storage with basically the Iceberg is one of them. So this is the same extension of the watsonx multi-query engine support, Lakehouse, this thing, that DB2 and Netezza are both there. So based on the requirements, it's high speed or high, the analytics they can be used accordingly. So that's the main integration, adaptation of the Presto in this environment. So other components, I'm not going much, IBM Watson Knowledge Catalog, Lakehouse metadata services and all that. So this is just to show that it's a multi-query engine support. They can work together well along with the Presto in this environment. So the next is, so the next I'm just going to discuss about the Apache Iceberg. It's a Java toolkit, open source Java toolkit that been used with these different engines. So for IBM Presto, we have the Presto Iceberg connector for the integration, Iceberg integration. For Netezza and DB2 and IBM Spark IA engine, we are using open source Java toolkit, which is available to use this thing. It's a GitHub project. So, so that I'll just give details on what you can do. So that's a Java Iceberg toolkit. It's a Java implementation, operations on the Apache Iceberg and both Hive tables. So you can, as shown, you can get the details of the table, schema, data files. You can write tables for many other things. But this is to just give you examples how simple it is to use and integrate, and which has been used by both IBM environment here. So you can see writing of the table, the writing of the table, some of the very simple cases we have been given on this. So the next is kind of a Presto Iceberg support. Some of the things that we have added from the IBM side for the PrestoDB and Iceberg connector. So some functions which are functionality which is ongoing, it's there. Row level deletes, merge on read support, it's there, which gives the performance while reading, writing, this thing changes. Time travel, I have implemented that. It's just there. It's not. It will come in the next release in the Presto for the Iceberg. Table register, unregister procedure is still, I think it's there. It's, you can add that. Some functions for partitioning this thing based on the column transform. So that is still there. It's going to be there. So this is to give the that it's continuing the functionality in the area of Iceberg connector and the PrestoDB. So yeah, I think that's it. I think that's it for me. Yeah, thanks. I'll hand over.
Thank you, Ajay. I will continue this topic to, like a case study to talk about the PrestoDB plus Iceberg to make them working together on the AI machine learning pipelines. I think probably you already got some ideas about how Iceberg working with Presto. Actually, this connector, we call it the Presto Iceberg connector. It's contributed by Twitter's Presto team, Zhen Xiao, Chunxu, and me, I think many years ago, at least 3 years ago. I think the very beginning, we more designed it for the analytics workload, which means it's more like an alternative to the Hive tables. We put the tabular table, which means the smaller columns in each table, right? But after I joined Alluxio, we are seeing more and more use case in the AI machine learning pipeline. They are using some data ingestion or pre-processing module. They are trying to retrieve the data from a data lake. Probably it's Hive data warehouse, probably it's just Iceberg table, whatever. So we are looking for a solution. We are looking for a solution which can make our life easier, which can support in the data pre-processing step, we can load different kinds of data like text file, like image file, video, audio files. So in this case, we are thinking about probably, because sometimes we are not just talking about a single line of data, we are talking about millions of lines, billions of lines of data. So in this case, probably we need Presto as a filter or maybe a data processor. We can do some aggregation, we can do some filtering, and also we can do some transformings or something. And we can also use the Iceberg as a data lake to keep the multiple kinds of data. And by doing so, we can make something like Presto plus Iceberg as a data engine. This can feed the data into the next step of the AI machine learning pipeline. In this chart, we can see on the most left part, is we are trying to process the data from a data lake or data warehouse, and we process data and we generate the training data, which means our more expensive GPU machines, they can just consume the data from our CPU nodes, which means it's highly selected data and we can have a more value or some more label or something from it. And then the data can be go to our GPU machine and train our model, and our model can write the model or maybe sometimes write some checkpoint. And after we have a good model, we make a model deployment life cycle, do the inference, do the for the downstream applications. That's the position of the Presto plus Iceberg in the machine learning pipeline. Okay. After we have a little bit exercise with our user and the customer, we found the diversity for the traffic pattern for each stage of the machine learning pipeline. Today, I will more focus on the first two stages, the data ingestion and the data pre-processing. So in this case, depends on different data format. It can be structured data, as I mentioned, more like analytics data format. It's a table. On the other side, maybe we can have some unstructured data like an image, like a video. So for these two kinds of data, it can be for the image or video, it can be sequential read. For the Parquet or ORC, it's more like a random read. Am I right? And it's also, as I mentioned, it's highly based on the data format we want to process. So in this case, we can see different challenge about data loading, data processing, because we are using different data format here. As you joined my previous session, you can see we are using a cache to support multiple data format like a Parquet, like a text file. But today, I will also share how the Presto Iceberg to work with some image file. And as I mentioned, we have different data patterns. The most important one is the sequential read. If you're talking about the image, the video, it's sequential read, am I right? But it's not always true. And also, we're talking about structured data, it's random. You can see if you're talking about random, they can maybe read from the very end, like Parquet, because each Parquet file, they have a footer. It's at the very end of the Parquet file. So always, if you are reading a Parquet file, you start from the very end, and you seek back to the very beginning, and you do some random jumping. Actually, it's based on some algorithm, but from the storage or the computer engine or the I/O perspective, it's more like a random read. But we'll load something like a video file, it's more like a sequential read. You read the data portion by portion. You can do some prefetch here. And the other challenge is the file size. If we're talking about billions of the small files, this will be a challenge. It's a big challenge to the storage engine. So now if we're talking about the AI machine learning data pipeline, we're talking about especially for some computer vision training, you may have billions of files here. So even though for each file is very small, but the number of the file can be huge. That's a big challenge for any of the storage and also the cache. Okay, then I will share a little bit about how the AI pipelines consume the data. Because now, in the previous slide, we know, okay, that we can have some data engine to generate the data to feed the training. But in this case, how does it consume the data? Mostly, if we're talking about large-scale machine learning model training, they may have multiple GPU nodes, and they may have a data set. So in this case, probably we will using something like a streaming, or we can say a queue. It's not always a queue, but sometimes looks like that. We process the data row by row and feed in a local queue and do some embedding or whatever, and then we copy the data or send the data. It can be in zero copy, GPU direct, but whatever. Send the data to multiple GPUs. Right? So in this case, you can see it's a producer on the left side and the consumer on the right side. So in this case, if you have a super strong GPU node here, maybe you have multiple nodes here, the data loading can be the bottleneck. And the requirement, or we can say the SLA, or the throughput, should be very high. If you have 64 A100 or H100 GPU card there, the throughput, or we can say, if we're talking about the image, you can take a look at this blog from AnySQL. It's the Ray. It's another open source AI training framework. They have some analysis about the throughput and also why they are using a streaming here. I won't go very deep from here, but I just want to say the throughput for the AI machine learning training can be very high. So in this case, we are thinking at the very beginning, we got some idea is, okay, let's put something like the metadata. Probably for each image, they may have a location, the author name, the size or something, data table. And we put the image itself, just like a raw file, is a separate file into somewhere. So this makes us a lot of, you may see a large number of small files on your storage. So here, I'm talking about, it's not the final solution, it's just an intermediate result, talking about the throughput. If we are working with the small file throughput, it's just a relative number. So you can see, here's the ray object memory, means the concurrency of your machine learning pipeline. So if you can see, if we have very low, a very high concurrency, you can see the S3 and Alluxio, they may get very similar throughput. So I'm using Alluxio here, I'm not selling Alluxio. I'm just talking about, because we always treat Alluxio as a much faster storage. We compare this one with S3. We can see, if we're talking about we are handling a large number of small files, even though we are using a more expensive and faster storage, there's no benefits. Just because for each small files, we need to build a connection, we need to transfer data, so we cannot show the value or the strength of a much faster storage. We can only show the higher throughput when we have very low concurrency. And in this case, okay, looks like we are good. So then we are thinking about, we put the image, put the binary of the image into the Parquet file. And in this case, still the same thing. The customer maybe have some query, they may have data pre-processing job, they pick up the data from the Parquet file, but meanwhile, they will try to load the binary, also the byte array from the Parquet file, which means we can highly reduce the number of files. So, which means they have much larger Parquet files. We put maybe each file contains 100 or 1,000 small images to each file. So in this case, we can see our value. We can see the blue ones is for here is for this row is the concurrency. We can see for no matter it's low concurrency or high concurrency, we can see a much better result, and also it's much higher throughput, which means we provide a better storage, and also we can speed up the machine learning process because this number is collected from the array. And also, I want to jump to conclusion quickly because based on the experiments we performed, looks like compare with put the small file separately in some S3 or HDFS, if we embed the small image into the structured data like a Parquet, and we use Iceberg to organize the table, looks like we can get a more efficient way to handling this kind of data, and we can provide a metadata, put the metadata together. And also, as we observed from our open source user, looks like using Iceberg plus Presto, this is more like a more robust solution because in the AI framework they using MySQL or something similar before. So if they have a large scale data, if they have billions of rows to process, now they have another choice. They can use the Presto to manage the metadata for each image file. And also, if we're talking about the read, why we by using Alluxio cache, they can offer a large throughput just because we fully optimize the position read. We can imagine that. It's go back to the traffic pattern of the data pre-processing. So we're talking about a single file, single image or video file. It's always a sequential read. You got the entire file from somewhere. You may call something like the metadata call, like a get file status or something. It might be at least 2 API calls. But if we're talking about the position read, which means you have a large file and you fetch data from something in the middle. And which means you only need to have one API call for the metadata of the entire Parquet file, and for each read, you only need to jump into some position. It's free, and to read a portion of the data. Because you already passed the footer of the Parquet, you already know where it is and how long it is, and you can just get data from there. It can at least two times bigger throughput than if you run the raw small files. I think that's it can speed up your machine learning training and also reduce your cost because for most cloud storage, the cost based on the number of API calls. So here is something we found by using Presto and Iceberg with the AI machine learning pipeline. Okay, I think that's all the result we want to share today. I mean, the Alluxio and the Presto community, we are still working on we will have more showcase about how to integrate about Presto into the AI machine learning pipeline. We may also have some integration with the vector database. We may also have some native solution about the Parquet reader, and also we want to highly speed up and make some deep integration with our technology, no matter it's analytics or AI. We want to work together with the community and share our best result. Yeah, here's everything I want to share today. Ali?